Welcome to Rosetta. My name is Sean Arms and I am a software engineer at UCAR Unidata. Today we will explore using the wizard interface to Rosetta to convert an ASCII-based data file into a data standards compliant, archive-ready netCDF file. For this demonstration, we will be using waveglider data from the SPURS Field Campaign project. The waveglider data comes in a space-delimited ASCII file with very little metadata. To begin the conversion process, we visit the Rosetta site and follow the instructions. First, Rosetta asks for some basic information. In this case, it's asking, what community do we belong to? We're dealing with waveglider data, so we're part of the physical ocean sciences community. And we're dealing with a waveglider, so we select glider. The next step asks for us to select our data type. In this case, we're dealing with a custom file type. That is, Rosetta doesn't know how to automatically convert the data type we're dealing with. The next step asks us to upload our data file. So we will browse, find our data file. In this step, the wizard is asking us to find what our header is in the data file. For this particular example, we have one header line. Finally, we select our delimiter. And for this file, our delimiter is white space. Now we see Rosetta has been able to parse our data into a table. At this point, we need to define what the columns of data are and add metadata to those columns. The first column contains information for time, in this case, the calendar date. So I will assign a variable name to this column. We'll call it calendar date. Rosetta's asking, is this a coordinate variable? Does it deal with latitude, longitude, time? Yes. What type of coordinate variable? In this case, it's date only. And what's the data type of the data in this column? It's just text. So now we can add some metadata about this column. In this case, we can add a comment. So something like calendar date. You can add a long name. If you don't understand what Rosetta's asking and you see a little question mark sign, you can hover your mouse over it and it tells you exactly what it is it's asking for, a descriptive name. For this, we could say something like date as seen on a calendar. Standard name is a name from the CF standard name list. For this, we're dealing with a time variable, so we can use time. And then units. Now, units on a calendar date might seem a little odd, so Rosetta has built in a unit builder. If we select the unit builder, we can say what type of data are we dealing with? Are we building units for? Date only. And this looks about right. Year, dash month, dash day. So I can select add to units, and now that is there. The rest of this panel asks for recommended and additional metadata, but for this demonstration, we will skip entering these for the sake of time. Using the same process, we can define the remaining coordinate variables, time, longitude, and latitude. Like the previous coordinate variable calendar date, time is a text value. However, longitude and latitude are numerical, in this case decimal values, so we make sure the variable data type reflects that. Now we move on to define the data variables. First up is salinity. Salinity is not a coordinate variable, and the data type is float. The required metadata looks largely the same as that required of a coordinate variable, However, there are many more pieces of recommended metadata. For this demonstration, we will skip entering any recommended metadata for the sake of time. This waveglider has two salinity probes, and the next data variable we define comes from the second probe. Much of the metadata we entered for the first salinity probe is the same for the second, so we can have Rosetta copy the metadata from the first salinity data variable to give us a jump start. At this point, we can update any metadata values as needed. The waveglider also measures temperature using two separate probes. These columns, along with a column containing the waveglider ID, will be ignored for the sake of time. The last step in the conversion process involves specifying metadata that describes the overall dataset. These metadata are classified as required, recommended, and optional. Any missing pieces of required metadata are highlighted in red. Once entered, click Next to proceed and initiate the actual conversion of your data. Now you can download the converted data file as well as a template that can be used to pre-populate Rosetta when converting new data from the same platform, or to be used as part of the batch processing interface to Rosetta, as shown in another video. Once you have converted the data file, tools that understand the climate and forecast data standards, such as the NASA Goddard Institute for Space Studies tool Panoply, can be used to easily view the dataset. Panoply can display the metadata as well as data on maps and create time series charts. We hope the wizard interface to Rosetta will help ease the process of preparing observational data for data archives while promoting data standards to ensure the future usability of these great resources.